Oh, it is such a beautiful thing teaching you guys every day. So, what we did on our warm-up real quickly is, I want to make sure I go through this. Girls, you're not talking, of course, you're paying attention. So what we're going to do is, real quickly, what we did is we looked at the equation, r equals 4 cosine of 2 theta, and I had you guys plug in all of these angles into this formula. Of course, as you change the value of theta, the radius will continue to change. So if the radius changes, Raul, then what happens is that you start to slowly get a different picture. And then what happens is you get some picture like this, and it goes like this, and Raul, it goes like this, and Jose, it goes like this. No, I think I might have missed that one anyway. So you get this weird looking flower, which, you know, then it comes back around like this, because the radius is constantly changing. So you can do that on your calculator, but you have to be a little bit careful. First of all, let's put some things down. So you're going to put this on your calculator, this graph right here in your calculator. We need to make sure, I did degrees, so I have to go degree mode. And I need to make sure I'm in polar coordinates, okay? Because this is not a function, so you have to graph it in polar. So I go to my calculator, I go to my mode first. In mode, I make sure I'm in degrees and polar. You can, of course, do this in radians, but we decided to do it in polar because it's easier for you to understand degrees versus radians, right? So then once I get that, I go to my window. I need my window to fit. Since I'm in degrees, I want to go all the way around the circle. I just made it go from 0 to 360, so I go all the way around the circle. Steps. So I wanted to graph angles by 1. If I made this into a 10, let me graph this real quickly. You'll see that it's pretty good, but it's a little bit blocky. If I go back to my window and make this by 1s, so I'm doing 1 degree, 2 degrees instead of 10, 20, 30, you get a much smoother looking picture. It takes longer to graph because you're doing every single angle, but you get a lot more accuracy out of it, okay? So,
why is that?
because I'm graphing 1 degree, 2 degree, 3 degree, 4 degree instead of
just skipping them?
It says just skipping them, yeah.
Could you still trace it and find those?
You couldn't, if you go to trace, it's just going to jump from 10 to 20, 30, yeah, okay. So then my window also, I wanted to make sure that I knew that it had a radius of 4 was the biggest, so on my window I made sure I went from -5 to 5 so it fit, and -5 to 5 on the Y and on the X so it fit, and when I graphed it, sure enough, that's what it looked like. Kind of cool, okay? It is obviously not a function, right? So you need to do this in polar coordinates, okay? So today, we take a look at our notes, all right? Let's continue this, all right? Now, we wouldn't want to do these by hand ever again. Let the calculator do the work for us. So first of all, example 1, r equals 3. Now I can actually do this. I like to go by half, so 1, 2, 3, 4. Before I graph this one, I'm actually going to use a little bit of common sense. I know that the radius is going to be 3 all the time. It's just going to be a circle. I know this is just going to be a circle. For a fact, it is going to be a circle, a regular old circle with the radius is 3. Now, let's check it out and see if I'm right. Of course I'm right. Of course I am. R equals 3. Graph. Well, you know it's a circle. What do I know? It makes sense. Now, again, it looks like an oval. We talked about this yesterday, or an ellipse. And the reason is because you have a rectangular screen, right? You have a rectangular screen, but it is a circle, all right? So if I want to graph that in, I could just go and make a circle all the way around, okay? What's the rectangular coordinate of the circle? Well, we know in our notes that r squared is equal to x squared plus y squared. So instead of writing r equals 3, I can write the square root of x squared plus y squared equals 3, because r would be equal to the square root of x squared plus y squared. Or x squared plus y squared equals 9, which is the equation of a circle. It really is in rectangular form. And we kind of talked about this a little bit in geometry and a little bit in algebra 2, okay? Now, example 2. You can't do this on a calculator. Well, why can't I do it on the calculator? What are you talking about? How? Well, the problem with the calculator is it just says r equals, right? You don't have theta equals. So how am I going to do that? Well, with a little bit of smarts, which we have. Pi thirds is an angle, right? Pi thirds is at 60 degrees. So if the angle is pi thirds, then the radius can be anything, but the angle is going to say pi thirds. So think about this. Here, my radius is changing, but I'm staying at pi thirds. My radius is changing, but I'm staying at pi thirds. My radius is increasing, but I'm staying at pi thirds, and it keeps going and going and going. We could also have negative radii, right? If I go a negative radius, I just go the opposite directions, but my angle technically is still pi thirds, right? If I go negative angle, I go the opposite direction. So, what do we get? We get a straight line, okay? Now, what is the equation of this line? Well, we're going to have to use a little bit of smarts on this one. I know that if it's a straight line, I could use y equals mx plus b, because it's a straight line, right? Linear equation. Slope, let's see. What is the slope of this line? Well, it would be basically the tangent of that angle y, because the tangent is going to be the y over the x. Well, that would be the y would be the rise over the run. So the tangent of any angle always gives you the slope. Has to, because the tangent is the y over the x, which is the rise over the run. So what's the tangent of pi thirds? Well, that's easy. It's on the unit circle. The tangent of pi thirds is the square root of 3. So that's my slope of this line. And the y-intercept is 0, right? It goes right through 0. So the equation of this line would be y equals the square root of 3x plus 0. Right? All right. Tell me when you're ready for me to turn the page. Thumbs up. Everybody good? Okay.
The square root of 3, then x, not square root of 3x.
Same thing.
Oh,
We're saying the same thing. Okay.
Okay.
Turn the page. Okay, now, graph 2 sine of theta. Well, let's let the calculator do it, right? Let's just go 2 sine theta. Again, we have to be in polar mode. We can do it in terms of degrees, right? And graph this. Let's see what this looks like. Okay. Okay, it's a circle, right? It's a circle with the center at this point here, right? So it's a circle. Okay, and let's go, again, 1, 2, 3. So we've got a 1, 2. So this graph looks like this. Here's my graph, okay? What's the rectangular equation of this? Well, I'm going to try and do this the easy way. I'm going to go back to geometry, and we learned that the equation of a circle came in this form: x minus h squared plus a y minus k squared equals r squared. That's the equation of a circle that we learned in geometry, okay? Okay, let me highlight this. Okay, that's the equation of a circle. So the center of our circle, the center of that circle right there is at the point 0, 1. Right? H would be 0. I'm going to put 0 here. K would be 1. I'll put 1 right here. And the radius of this thing is 1. Right? So the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center of the circle is at hk. That's the center. And the radius is just whatever the radius is. So the radius is 1 in this case. So the equation I'm going to write is an x minus 0 squared plus a y minus 1 squared equals a 1 squared. And of course, I'll fix that, but that technically is, without simplifying, the equation of that circle in rectangular form. Okay, that means xy, okay? So obviously if I simplify this, it's just going to be an x squared plus a y minus 1 squared equals 1, okay? Alright, last one. R equals 4 cosine of 3 theta. Now we did the one in our warm-up with the 2 theta, and it looked like this, right? So 3 theta, what do you think? Any guesses what's going to happen with 3 theta? Instead of 2 theta, what do you think?
Less than.
It's going to have more flowers, isn't it? It's going to have more petals. Let's check it out. So let's go ahead and go 4 cosine of 3 theta. In fact, Sarah, what did you do? What did you do? Didn't you do 1,000 theta? Yeah, and you had a lot of petals, didn't you?
Mine is making triangles.
It's X.
Okay, is yours making triangles? I'll take a look at it in a second, okay? It should look like this.
Mine is making triangles.
Oh, it did, yeah.
I like reading those. It makes cooler shapes. Where's that?
All right, did everybody get that? Isn't that cool looking?
Just for 4.
So,
Yeah.
we're going to go, it looks like it has a radius of 4. 1, 2, 3, 4, right? So it looks like this. Okay, it's got a flower there. It's got a flower there. Oops, I'm off a little bit. Flower there, okay. Isn't that cool? This one's a little off. Does it have symmetry? It has symmetry, yes, it does. And it depends on where your symmetry is. Has symmetry with 0 degrees. Has symmetry with 120 degrees. It'll have symmetry with 240. So it has symmetry, yes, at theta equals 0. Symmetry? How would you call symmetry? How would you? Okay. Theta would equal symmetry of 120 degrees, or theta equals 240 degrees, okay? Now, you can do it also in terms of radians. Of course you can. But if you do it in radians, you have to just think about your window, right? So real quickly, I'll show you the difference if I did this one in radians. Okay, you watching? You listening? If I want to do this in radians, you can do it in radians. So if I did it in radians, I go to my mode. I could change it to radians, right? But when I went to my window, I'm going to go from 0 to 2 pi. My steps. Now that's 1 radian, which is like 57 degrees. You wouldn't want your first point at 57 degrees. You'd want a whole bunch in between. So if I go by 0.1 with radians, 0.1 radians, right? I get a lot more detail, okay? And let's see how that looks. Should be the exact same picture pretty much, but that's in terms of radians, okay? Let me go back to, real quick, I want to go back to my window. Let's go back. I want to go back to degrees and show you something. Come on, mode. I want to go back to degrees. Enter window 0 to 360 by 1s and graph this. Because, Jose, you asked a really good question. You asked, well, can I trace it? You can. Let's do a trace button, see what happens, all right? So if I go to my trace, come on, stop, it's not done yet. Come on, trace. So I get theta and an xy value. Isn't that cool? Move it along. You get your angle and all the different xy values, which is kind of cool because you get, not only do you get it as an angle, but you get a corresponding rectangular value for it too, don't you? Right? All right. So